So now that we've assigned labels to our angles and to the sides of our triangle, let's move towards the math part of it, okay? So the next conversation is about the relationship of sides, okay? And there's a very specific, a very well-defined relationship between the sides of a right angle triangle. So if we begin with a right angle triangle that has a very small angle, okay, so here's our angle theta, okay, and our angle theta is a fairly small angle. We have a particular shape to our triangle. As we move forward and we stretch that triangle out, okay, so the angle theta gets bigger, okay, the shape of our triangle changes. As we carry on, and now our angle theta is quite large. Okay, again, the shape of our triangle changes. So it continues to change as our angle changes. Okay? The point is that there's a very specific relationship that happens here. Okay? If we compare the opposite and the adjacent, okay, in the beginning with a small angle, the adjacent is a very large length, okay, it's a longer side, as opposed to the opposite, which is going to be a very short length. Here, okay, there's a spot here when the angle theta equals 45 degrees, okay, check this out. The other angle up here that we don't care about, what is it? Well, it's also 45 degrees. 45 plus 45 equals the 90 degrees that those two must add up to. And so at this point, the opposite is going to equal the adjacent. Okay, whatever they are, okay, the magnitude doesn't matter. This could be a very small triangle, this could be a very big triangle. Okay, the magnitude, we haven't got there yet. But this relationship will always be true. These two sides with a 45-degree angle, the opposite and the adjacent, the adjacent and the opposite will be exactly the same length. Okay, and then as we move on, as the angle increases, okay, here is our adjacent, which is now getting extremely short, and here's our opposite, which is now getting much longer. Okay, so there's a relationship here which will always exist. Okay, for any given angle, the ratio between the length of one side compared to the other will match. Okay, that's what the relationship of sides is all about. Mathematically, what does this look like? Who remembers the term SOH? TOA. Anybody heard that before? From high school math class? SOH. This is a mnemonic to remind us of the equations to allow us to do these calculations about the relationships of sides. Okay? S stands for sine. Oh, that marker's not going to make it. So, sine. This is a function that you can find on your calculator. Okay, I'm not going to ask you to do this math in your head. Okay, but the sine of the angle theta, okay, and this speaks to that relationship I was just talking about, the ratio between the opposite and the adjacent as the angle changes. So if you calculate the sine of any given angle, okay, 10 degrees, 45 degrees, 85 degrees, okay, it will equal the ratio of, so SOH means the sine of the opposite over the hypotenuse. So if you know the length of the opposite and you divide that by the length of the hypotenuse, it will give you this relationship for that particular angle theta. Next, let's move on to the second half of the mnemonic, CAH. And C stands for cos. So this is another function that you can find in your calculator. Okay, and the cos of the angle is equal to AH means adjacent over hypotenuse. Okay, so whatever the value is of the adjacent divided by the length of the hypotenuse, this will give us a relationship which represents the cos of whatever that angle happens to be for that particular triangle. These relationships will always be true. Let's move on to the third one, which is tan. And the tan of the angle theta equals OA means opposite over adjacent. Okay, so in that example I was talking about before, the tan of the angle 45 degrees, okay, so when the angle is 45 degrees, the opposite and the adjacent will be the very same length. So whatever they happen to be, I'm just going to use a placeholder x, okay, but the opposite, if the opposite equals x, then the adjacent also equals x, okay, because they're equal, they're the same at 45 degrees. So the tan of 45 degrees is going to be 1. It's always going to be a number divided by itself, because the opposite and the adjacent will be the very same value. Okay, so that's what SOH is all about. It's a consistent relationship. No matter what the numbers actually are, how big or how small the triangle actually is, the relationship between one side compared to another side at a particular angle will always be predictable. We can calculate it. Okay, we're not going to calculate sine, cos, and tan by hand. We're going to let the calculator do that work for us. Okay, but we can always come up with the answer if we know one of the sides and we know the value of the angle of interest. Okay, we can always find the other side because the relationships drawn right here will always be true. Okay, one other relationship that will always be true. So this is we've got one side and we've got an angle and we want to find another side, or we know two sides and we want to figure out what our angle is. Okay, mathematically we can manipulate these equations so that we can find variables that we don't know. Okay. One other method of doing that. Okay. So SOH, sine, cos, and tan, utilize a mixture of sides and angles. Okay, I'm going to draw my right angle triangle one more time. Angle theta. I keep flipping it back and forth. It doesn't matter. Okay, we can pretty much do whatever. So the sine, cos, and tan, if we know a side and an angle, we can find another side. Or if we know two sides, we can find the angle. Okay. The other thing I want to talk about is if we know two sides, we can find the third side. Okay, and this piece of information comes from Pythagoras. I always struggle with the spelling. Pythagorean Theorem. Pythagorean Theorem. I'm not sure if that's right. That's close. Sorry, that's probably something I should figure out. I seem to have always struggled with that. The Pythagorean Theorem, okay, developed by Pythagoras, tells us about the relationship of the three sides. Okay, and if I say that this is A and this is B, so we assign the hypotenuse the value of the value of C, the Pythagorean theorem says that the square of the first side plus the square of the second side will be equal to the square of the hypotenuse. Okay, so we already established the fact that the hypotenuse will always be the longest side, and so it's the square of the other two sides added together that equals the square of the longest side. Okay, we can do all kinds of algebra to manipulate this, and we could say that a squared is equal to the hypotenuse squared minus that other side squared. Okay, so when we want to find A or B, it's going to be C squared minus the square of the other side. Okay, and of course we always want to isolate on one side of the equal sign or the other just the value, and so we need to move this square over to this side, and here we need to move this square over to that side. Let me tidy this up. let's go with c squared equals. Okay, so we're trying to find the length of the hypotenuse. C squared equals a squared plus b squared. Right, there it is. C squared equals a squared plus b squared. Okay, but we don't want to solve for c squared. We want to solve for c. So what we need to say is c equals. So what does c equal? Okay, when we move the square across the equal sign, it becomes a square root. And so c equals the square root of a squared plus b squared. Okay, so here's another relationship that we can always be certain will be true. Okay, the square of the two shorter sides will add together to equal the square of the hypotenuse, the longest of the three sides. Okay, always. Now, just to put some numbers in here for you, watch this. I'm going to erase that so we don't have to look at that horrendous spelling any longer. In carpentry, they use this all the time. Okay, all the time. Because they know that if they want to determine if this corner is square, okay, so here they are. They're building a house. Okay, they've just built these walls, and they want to make sure that this corner is square. Okay, you measure from the corner in one direction and go out 3 feet, 3 meters, whatever you want it to be, 3 meters. Okay, and then measure out here and put a mark right there. Okay, measure here out 4 meters and put a mark. And then take your tape and measure from that mark across to that mark. And if it is not 5, your corner is not square. 3, 4, 5. Okay, well, let's do the math. That means that 3 squared plus 4 squared must equal 5 squared. Okay, that's the Pythagorean Theorem. That must be what this means. Well, let's try it. 3 squared, so 3 times 3 equals 9, plus 4 squared, 4 times 4 equals 16, equals 5 squared. 5 times 5, 25. 16 plus 9 is 25, equals 25. Looks good to me. Okay? So, carpenters do that all the time. Anytime you want to check and make sure you've built a square corner, measure 3, 4, and 5. Okay? If this is less than 5, that means these two walls are too close together and your corner is less than 90 degrees. If you measure more than 5 feet or 5 meters, whatever you happen to be measuring, that means that these walls are too far apart and you've got an angle there that's greater than 90 degrees.